There we go. Oh my God, I wouldn't record. All right, 7.5 operations with matrices. So we're going to be doing adding, subtracting, multiplying, and dividing. And we lost somebody, but I don't know who. Okay, now I know who. And if you need a calculator, it's desmos.com/matrix. Cool, cool. Great. So first key concept, write it down if you want to, but basically the idea of equal when we're talking about matrices is that they have to be exactly the same size, and each element in one has to be the same element in the other. Does that make sense? Which makes sense. I mean, I assume that would already make sense to you. It's kind of common sense. We just didn't have a formal definition of it before. So for you to be able to say two matrices are equal, they have to be exactly the same size and they have to look exactly the same. Cool? We're okay using that? Liam, are those ears connected to your headphones or are they separate? They're connected?
You put them on the headphones.
I love it.
Thank you. Ella got them for me for Valentine's Day.
I love them. They're quite nice. Okay, so using that property, for example, when we want to solve for each element, so I could say, I'll give you some time to write it down actually, because I don't want to rush you after I already made you panic for 10 minutes. Come on. So if I asked you, what is element A11, would you be able to answer that question? If you think you can answer that question, tell me in the chat. What is A11? Great. Looks like you guys pretty much already know how to do that for everyone that responded in the chat. So A11, this first element corresponds to the number 2. So A11 would be 2. Cool? Nothing crazy? A pretty simple lesson. Tell me in the chat, what is A22? What is A22? Great. Looks like you guys are professionals already. So if we went ahead and filled them in, A12 would be -1, A21 would be -3, and then A22 would be 0. And I don't know why my screen keeps pausing. Can you tell me if at any point during the lesson it's not showing you what I'm saying, because my computer's having a rough time right now. It keeps pausing my screen for no reason. You guys can see me writing, right? Okay. Great. Uh-oh, now it's not gonna let me delete that. Okay, there we go. All right, so for it to be equal, we want them to be the exact same size and each element corresponds to the same place on the second matrix, right? We're okay with that? Great. Next key concept, when we're talking about adding and subtracting or multiplying and dividing, we're not going to do dividing yet, but for adding and subtracting, each element adds with the same element in the same place. So A11, you'll add A11 and B11 together, and that will be your new element. So you're just adding in the same place. I know, gosh, Liam, you're right. It's having a rough time. So if you've already seen the discussion, that's basically what you're doing this week is you're going to start with someone else's matrix. You're going to add different things to it, and you want the end result to have all the same number, whatever number you want. So if you want it to be all 5s, it could be all 5s. If you want it to be all 6s, it could be all 6s, whatever you decide. Cool. And then when you're multiplying a scalar multiple, whenever we're talking about matrices, it's always going to say a scalar multiple. That's just meaning a real number that you're multiplying by. like 5. And to multiply by a number, you would multiply everything in that matrix by that number. So if it was like 5 times the matrix, then you multiply everything in the matrix by 5. Cool? Great. So like I said earlier, a lot of these are going to be easier to do by hand. Some of them are going to be easier to do on the calculator. So you could go to the calculator. Oops, this one has the answer in it. Oh well, it is what it is. You could go to the calculator and you could type it in exactly like that on the Desmos matrix calculator and it will give you the answer, but it's probably going to be more work to do it on the calculator than it is to just do it in your head, right? So for us to be able to add, they have to be the same size. So for this first one, our first element, you're going to do -1 plus +1. Our second element would be 2 plus 3, 0 plus -1, and 1 plus 2. So you're adding the ones that are in the same position in each matrix together to get your answer. And again, did not mean to include the answer there for part B. Oops, I'm not writing anything else. I stopped writing already.
But I know you're about to keep going.
No, I saw your button. I mean, part B I already answered on accident. So it is what it is there. So same position, add them together. So that's how I got -1 plus +1. That's how I got 2 plus 3. That's how I got 0 plus -1. And that's how I got 1 plus 2. Then you would go through and you would actually add those together. So -1 plus 1 is 0. 2 plus 3 is 5. 0 plus -1 is -1. And 1 plus 2 is 3. Cool? So like I said earlier, you can literally go to the Desmos calculator. You could type it in exactly like that and it will give you the answer. But for adding and subtracting, it's going to be less work to just add or subtract because you could do that in your head. For the second one, again, didn't mean to include the answer there, but if we were doing the work, it would be 1 plus -1, -3 plus 3, and -2 plus 2. And that's how we got that answer of 0, 0, 0. For the third one, because they're not the same size, you can't add them together. So if you went and tried it on Desmos, you should get an error or something along those lines that says that you're not able to add them. They have to be the same dimensions for you to add them. Cool, cool?
Would it just be like no solution then?
Yes. So on WebAssign, I think what it says to do is like it has the buttons for you to change the size of the matrix for you to type your answers in. If the answer is not possible, you just pick any of the boxes and you write the word impossible in all caps and then submit it. And there are a couple on your homework where the answer is impossible. Example 3, you ready for it? You look pretty ready for it. Okay. Now we're going to do a scalar multiple. So we're finding 3a. So again, you could go to the Desmos calculator. You could type in this matrix. Then you could type in 3a. But it's probably easier for you to do it in your head because you can multiply by 3 probably in your head faster than you could type out the whole matrix and then type in 3a. Right? Okay. I'm going to give you a couple more seconds to write down the matrix because I know I'm talking while you're doing that. Just trying to pass some time while you're writing. All right, so 3a means we're multiplying all of these by 3. We're multiplying every single number in that first matrix by 3. So 2 times 3 2 times 3, 4 times 3, and so on. I'm not going to write all of those out because I think you'll understand the idea of multiplying by 3. So our matrix for 3A would be 6, 6, 12. Our second row would be -9, 0, -3. I forgot what we were multiplying there for a second. And then our last row would be 6, 3, and 6. Do we have any questions so far on adding and subtracting or on multiplying? Do we feel pretty confident in all of those? Okay. That was what I was hoping. It's a pretty simple lesson. I assumed you would be okay. Okay, now we're going to take it a step further and we're going to combine all of the operations. Are you ready for that? Okay, so I want to point out for example 4, matrix A is the same matrix that you just used for example 3. So we already did 3A, the part in the beginning. However, if you wanted to go and do this on the matrix calculator, you could type in A equals and type in matrix A. You could type in B equals and type in matrix B. And then in the third line, you could type in 3A minus B, and it will tell you what the answer is. Or you can do it by hand. In 1 minute at 2:13, I'll go over the question. Okay, it's 2:13. So we'll do 3A first. So that one earlier was 6, 6, 12, -9, 0, -3, 6, 3, 6, minus B, which is that same matrix 2, 0, 0, 1, -4, 3, -1, 3, 2. So you could do it element by element. So you could have taken the first one, and you could have done 2 times 3 plus 2, and then 2 times 3 plus 0. So like this, 2 times 3, minus 2. You could do it that way, however your brain thinks about the question. I'm going to do it this way. So I would do 6 minus 2 for my first element, which is 4. 6 minus 0 for my second element, which is 6. 12 minus 0 for my last element, which is 12. Are we okay with those 3 pieces? So I'm just taking the ones from my 3A matrix and I'm subtracting the ones from my B matrix. So my second row, I'm going to do -9 minus 1, which is -10. 0 minus -4, which is +4. -3 minus 3, which is -6. 6 minus -1, which is +7. 3 minus 3, which is 0, and then 6 minus 2, which is 4. And then we would have our answer there in that new matrix. So again, if you wanted to do it on the Desmos calculator, you could go in first line, you could type in A equals and type in the first matrix. The second line, you could say B equals and type in the second matrix. And then in the third line, you could say 3A minus B, and it'll tell you what that matrix is, and it should be the same as this one. Cool? Can you give me a green yes if you're using the matrix calculator, like to do this? Green for yes, red for no. Are you using the matrix calculator right now? I'm just curious. Okay. Well, if you're using the matrix calculator, tell me at any point if my answer doesn't match, because obviously if I'm doing it by hand, there's some possibility that I did things wrong. Like earlier, I forgot we were multiplying by 3. Understandable. Okay, you ready for example 5? Moving on. Great. First, we have a key concept. Main ideas for this key concept: treat it addition, subtraction, and multiplication the way that you normally would, that we did previously in the lesson. We have this matrix 0 or O. That is an additive identity. Basically, it doesn't change the value when you add it to any other matrix. So that's only referenced here in number 5, which I feel like that one probably makes sense. If you add nothing, obviously the answer is going to stay the same, right? And then also that distributive property still applies even when you're talking about matrices. And that would be our other examples. Cool? Nothing crazy? Basic properties. Can you guys give me a ta-da when you are ready to move on? Two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, All right, I think I got one from everybody. So for example 5, you're using distributive property. Like I said earlier, it's entirely up to you if you'd rather do them by hand or if you'd rather do them on the calculator. For this question, it's probably the same amount of work either way. So I'll let you guys decide how to do it. But essentially, since there's a 3 on the outside and parentheses around both of the matrices, you would multiply them both by 3 and then add them together. Or you could add them together and then multiply the answer by 3. You'll get the same answer either way. Cool? You want me to let you guys try this one and you can tell me the answer? Okay, when you type in your answer in the chat, do row 1, like the first number, the second number, and then just like, then do row 2. So row 1, or first answer, space, second answer, and then for the second row, just type in all in one row. Cool? I think it'll work for us. Or you could put commas in between. Ooh, you beat me to the first row. Beat me to the whole answer, I think. Yeah, that's right. Or that's the same answer I got at least. So I hope it's right. So again, whichever you feel like is easier or less work, do it that way. If you think writing it on the calculator is less work, do it on the calculator. If you prefer writing it by hand, do it by hand. Bella, I got the same answer as you. Aiden, I got the same answer as you. Alexis, I got the same answer. Okay. Jocelyn, I have the same answer. In 1 minute, I'm going to go over it. So send me your answers in the chat. Natalie, you're correct. (222), I'm going to go over the question. Again, by all means, if you're waiting, you could pull up the homework, try to work on it there. Probably won't take you very long to do this assignment. Liam, I got the same answer. All right, is 222. So I'm going to do it by multiplying them both by 3 first and then adding it together. So if I'm multiplying both by 3, my first matrix is going to be -6, 0, 12, 3. And my second matrix is going to be 12, -6, 9, and 21. I hope I did my math right. Then we would add them together. So if they're in the same place, you just add them together. So -6 plus 12 is +6. 0 plus -6 is -6. And that's our top row. And our bottom row, 12 plus 9 is 21. And 21 plus 3 is 24. Cool? If you prefer doing them by hand, I would maybe, especially if you get them wrong on WebAssign, I would go back and check them on the calculator, because it's definitely possible that you can multiply something wrong or be like me and forget that we're multiplying by 3. You know, you get the drill. All right, moving on. Example 6. Great. We can also use matrices to solve for equations using the same process that we did earlier. So using A and B, we want to solve this equation. Give you some time to write it down, or maybe try it out if you feel like you know what to do already. Anybody have an idea of what they feel like we should do? No? Great. So if I was looking at this equation, how could you solve it for x? No ideas? Are you still writing the question down? I rushed you a little too far. Okay. All right, Luis in the chat said that we should subtract a from both sides. And I do agree. So we would have 3x, that doesn't look like a 3. 3x equals b minus a. Are we okay with that part? From here, we would want to divide by 3 because we want x to be by itself. When we write that as a matrix, though, it's actually going to be written as 1/3 because we always want to think about these as multiplying. So we want to find matrix B minus A, and then we want to multiply everything in that matrix by 1/3. Does that make sense? Yes? Great. Do you want me to go over that part and actually find the matrix, or do you feel like you could probably get it from there? Give me a green for yes if you want me to finish the question, red for no if you feel like you could get it from there. have almost a majority. All right, I think I got to a majority of yes. So I'll continue over the question. So we're going to do b minus a first, and then we'll multiply it by 1/3. So b minus a. So -3 minus 1 is -4. 4 minus -2 is 6. Confuse myself there. 2 minus 0 is 2, and 1 minus 3 is -2. Then we're going to divide them all by 3 or multiply them all by 1/3. So our answer would be -4/3 for the top one. 6 divided by 3 is 2. 2 divided by 3, I'm just going to write as 2/3. And then -2 divided by 3, I'm just going to write as -2/3. So our answer for x would be this matrix here. So I know some confusion that comes up from here is we think that we might have just a value for x, but because this was written as a capital letter in the beginning, you're solving for the matrix x. So you're solving for the entire matrix. Does that make sense? Okay. All right, we're on to the last thing. Are you ready for it? Now we have multiplication. Yay! Can I get a little more excitement? Like a ta-da or something? Much better. Okay. So you're probably not going to want to write this key concept down because it looks super confusing. Basically, when you're multiplying, you're taking the top ones and you're turning them sideways and you're multiplying by the first ones, and that's going to go in your first box. So there's a whole bunch of examples for us to practice it because it is a confusing process. However, you also have the option of using the calculator. So again, whatever is your preference, whatever you feel like is less work for you. And then the last thing I wanted to point out was at the bottom for your dimension for your final answer is always going to be whatever your rows were in your first matrix and whatever your columns are in your second matrix. Does that make sense? Great. All right, are you ready to try it? You guys look a little iffy. So very first one, we have matrices A and B, and we want to multiply them together. Give you some time to write it down. At 2:30, I will go over it. I will explain that part in just a second. Okay, so one of the questions I got in the chat is how are we able to multiply them if they're different sizes? Oops. So the first matrix is a 3x2. It has 3 rows and 2 columns. Our second matrix is a 2x2. As long as these two in the middle are the same, you can multiply together. Doesn't matter what the outsides are. The outsides are actually going to tell us the matrix that it's going to be at the end. But as long as the two in the middle are the same, then you can multiply. Cool? So we're going to multiply those two together because they both have 2's in the middle. Our answer is going to be a 3x2 matrix. So here's the process of multiplication. We take our first row and we multiply it by our first column. And that is going to be our first element. So we have -1 times -3 plus 3 times -4. So first row times first column, add them together, and that's your first element. How are we feeling about the very first step? Okay, let's try our next one. So now we're going to take our first row and we're going to multiply it by our second column. Let me highlight in a different color. So first row times second column now. So -1 times 2 plus 3 times 1. So this might be an example where using the calculator is probably less work. For our second row in our new matrix, we're going to take our second column. Our second row, sorry. Our second row and multiply it by our first column. So 4 times -3 plus -2 times -4. I got lost. I'm going to stop highlighting now because I feel like I'm going to have way too much highlighted. But our next one would be 4 and -2 times 2 and 1. So 4 and -2 times 2 and 1. So hopefully you see those rows carrying through and you see the columns carrying through as well in your final answer. Realize I made mine a little too big. And then our last one, we're going to do 5 and 0 times each of those two columns. So 5 and 0 times -3 and -4, and 5 and 0 times 2 and 1. Oh no. From here, you would go ahead and evaluate each of those expressions on a calculator or in your head. So -1 times -3 is +3. Minus 12 gives us -9. Got confused for a second. -1 times 2 is -2. 3 times 1 is 3. -2 plus 3 is -1. Nope, +1. 4 times -3 is -12. -2 times -4 is +8. And -12 plus 8 is -4. For the remaining 3, I want you to try them and tell me in the chat what you get as your answer. Do them as the first number, the second number, and the third number. And just put a space in between. So if you did it on the calculator, you can just copy down what those numbers are. If you're doing it by hand, calculate them and then tell me what they are going to be. Aiden, you're correct. Luis, you're correct. For the sake of time, I am going to go over them right now. I did not realize what time it was. So our first one would be 4 times 2, which is 8, and -2 times 1, which is -2. So 8 minus 2 is 6. And then for our last row, 5 times -3 is -15, plus 0 is just -15. And then 5 times 2 is 10, plus 0 is 10. So that would be our final matrix, and this would be our answer to the question. So you could go to the calculator, you could type in matrix A and matrix B, and then in the third line, just type in AB or A times B. It'll give you your answer, or you can do them by hand. Whenever I see you guys on Thursday, Friday, right? Yeah. Whenever I see you guys on Friday, we'll review a little bit